Welcome to standard deviation. You've talked a lot in the past about measures of central tendency, the mean, the median, and the mode. If you don't know what those are, you need to learn those before you learn standard deviation. If so, let's say we want to know how accurate we are. We need to know how good our measure of middle fits our data, okay? Or how closely it describes your data. Well, for mean, there is a number that kind of measures the spread of your data. It lets you know how close to the mean the rest of your data should be. And that measure is called standard deviation. So let's say you go on an interview for a job and the interviewer says that the average income for the company's employees is $60,849 per year. So that sounds pretty good, right? You're going to make over $60,000 a year. That's not too bad. But when you investigate further and look at the list of annual incomes for the employees of the company, I want you to just take a second to look through this list and see how many of them are over $60,000 a year. There's not very many, right? Well, looking at my three measures of central tendency, the mean is over 60,000. The person didn't lie, right? The median, however, is 33,450, which means that half the company is making more than that amount and half the company is making less. The mode is very telling, right? Mode means the number that occurs most often. So more people in the company make $12,500 per year than any other salary. So which do you think is the best measure of how much you would get paid if you were offered a job with this company? So think about that for a second. Think about why the mean is so much higher than the median, and we'll come back. So if we really want to find out how factual data is, we use standard deviation to give us an idea of how far spread out the data is, right? How spread out my numbers really are. So to learn how to do standard deviation, we're going to start with a list of only 4 numbers. When you find standard deviation, the first thing you want to do is find the mean. So we average our numbers, and I found that my average is 4. Okay? Then we're going to make ourselves a chart. I'm going to list all the numbers in my list. For now, that's only 4. Imagine how or what a pain this chart would be if it was very many numbers, right? And remember, my mean was equal to 4. So now I need to look at how far the numbers are from the mean, or in other words, the difference from the mean. Well, 4 has a difference of 0, right? It is the mean. 8 is 4 numbers away from the mean. 3 is negative 1 away from the mean, and 1 is negative 3 away from the mean. So these are the differences from the mean. In the third column, I'm going to take those differences and I'm going to square them. So 0 squared is 0, 4 squared is 16, negative 1 squared is 1, and negative 3 squared is 9. The last things I want to do is find the average difference from the mean squared. So I'm going to average this last column. So if I add them up, I get a total of 26, and I'm going to divide that by the 4 numbers. That's going to give me 6.5. By the way, this number is called variance, and variance has a big place in statistics. So my average difference from the mean squared is 6.5. If I square root this average, so square root 6.5, I get approximately When I'm rounding to 2 decimal places, I get 2.55. This number is the standard deviation. So this is an important number to know. This kind of tells me that most of my data is within 2.5 approximately units away from my mean of 4. Okay, so 2.55 is not a very big number. That means the rest of my list is pretty close to my mean. So going through that process one more time, let's find the standard deviation for this list of numbers. So I make my list of numbers and I want to find their average or their mean. I get 92.3. Next, I need to list how far away each number is from my mean. I take that second column and I square every number. I'm going to average that third column. That number's my variance. And when I square root that number, I get my standard deviation. There is an actual formula to show standard deviation. Remember that the symbol sigma means to add things up. So we're going to add or find the sum of a whole bunch of numbers. So then we're going to add some more notation to it. Let's look at that notation. N stands for how many numbers are in your list. That's how many data points you have. So I'm adding up all of my numbers from my first number to my nth number. The I tells us what data point you're using, so 1, 2, your first point, your second number, your third number, whatever. X sub I is the value of your data point, so X represents all the numbers in your list. Mu, remember, means the mean. So this is where I'm finding how far away from the mean each number is. This is taking the difference and squaring it. This is adding up that whole third column, and dividing by n takes its average. And when you square root that number, you get standard deviation. So this all is done to find standard deviation. So really quickly, back to our company and their list of salaries. The standard deviation for that company was over $99,000. So that's a pretty big spread, right? That means that most of the company is making within $99,000 of the mean. That's a really big spread. That means that your mean was not a very good measure of middle. So, take the time to think about that for a minute. If you need more examples on standard deviation, remember Khan Academy is a great resource. Have a great day, and I'll see you later.